Good evening, welcome to Maths with Sod. Today I am going to introduce you a new chapter for grade 6, that is integers, and I am with Ila. So let's start integers. So first of all, Ila, I would like to make you understand what are the important points that you should understand in integers. So what is the smallest integer? If I ask you, what is the smallest integer?
Minus infinity.
Wonderful. It is negative infinity. What is the largest integer?
Infinity.
It is plus infinity. Okay, if I ask you what is the integer with no sign? Can you tell me the integer which have no sign?
0.
3?
0.
Okay, 0. Okay, and positive integers are also known as known as. Can you tell me what it is known as? They are also known as natural numbers. They are also known as natural numbers. All right. So integers can be represented as z plus. Z plus means I am writing n. N stands for natural numbers. So natural number starts from where? Starts from 1. Natural number starts from 1, and positive integers also starts from 1. If at all you will ever see somewhere it is written in the book or anywhere that you should always consider the positive integers, that means they are asking you to consider natural numbers. Positive integers and natural numbers are same. All right. Okay. Then there are some properties in mathematics. There are 5 basic properties. I think there are 6 basic properties. Okay. So you should understand, first there is a number system. Then in that number system we have properties, and in those properties we do operations. This is how maths goes. What are those operations? They are addition, they are multiplication, they are subtraction, and they are division. First of all, you should understand that there is a number system. In those number system there are properties. How many properties are there? There are 6 basic properties. 6 basic properties of mathematics, and we will come one on one for each. So the first property is known as closure property. First property is known as closure property. Okay. So suppose you think somebody is married. Okay. A new couple has been married and they have been locked into a room for 2 years. They have been given the food and television, everything is being given to them. After 2 years, if they come out, is it possible that they come out, suppose they are coming out, they were 2, now they are coming out as 3. They have got a baby. Is it possible the baby is a dog? No. When human beings enter inside, what is coming outside is the human being. So if you do a operation on integers, suppose 2 integers z1 and z2 are added and the result is an integer, we say that integers are closed under addition. You lock a person inside and the same type of result is coming outside, we say that it is closed or it is open. So this is closed. Okay, so we will say integers are closed under addition. Please write it down. Whatever I am writing, you should also write. Integers are closed under addition, and if you are having any doubt in any sentence that I am writing, please stop me, because you are the only one in the class. You can stop me at any time, any point. You can ask me as number of times as you want. All right? Okay. Now the second point. See, we can say that multiplication is a continuous addition. Can we say like that? We know that multiplication is a continuous addition. If you don't know, see this. If I ask you to add 13 5 times, so will you add 13 5 times, or you will do multiplication of 5 by 13? Tell me. What is
The second one.
the second one? So that means the continuous addition is also multiplication in mathematics. All right. So whatever properties is there for addition is also valid for multiplication. So we will say integers are closed under multiplication. Okay. So how you can change z2, and always you will get an integer only. If you don't get it, tell me an integer. Suppose you want to prove anything wrong, so you just need to give one example. If I say anything is right, you just need to give one example to counter it. Are you getting it?
Yeah.
Just one example. Since you don't have any example, so whatever I am saying is correct. You take any two integers, you multiply them, you will always get an integer. Let it be 0, positive, negative, any integer. Now coming to the third point. What about subtraction, dear? Tell me, if I subtract two integers, will I get integer only?
Yeah.
Yeah. Okay. So since you are agreeing to this, I am also in agreement with you. So I am writing integers are closed under subtraction. Integers are closed under subtraction. Are you getting what is a closure property?
Yes, sir.
You do an operation on a particular type of number system, and you are getting the same result. Integers doing an operation, getting an integers means they are closed, or else they are not closed. So integers are closed under, we can say, addition, multiplication, and subtraction. Now you know, do you know that division is a continuous subtraction process? You know this?
Yes, sir.
Okay. Can I say that I divide two integers and I will get an integer only?
Yeah.
Sure?
No, actually, yeah, you can't.
We can't. Because if I divide 2 by 3, I am getting 2 over 3. This is not an integer. This is a fraction. Okay? So that means whatever thing is valid in subtraction is not valid for division. So we will say that integers are not closed under division. Integers are not closed under division. Got it? Written as well?
Yes, sir.
Okay, you are so fast. Okay. Now coming to the, so what is the second property in mathematics? You know? What is the second property is mathematics? Commutative. What is the second property? Commutative. What does commutative means? You add two numbers in any order and their value won't change. You multiply two numbers in any order and their value won't change, and we know this. You know this?
Yes.
Then if this property is being applied for integers, can we say that integers are commutative under addition and multiplication? Yes. So we will say integers are commutative under addition and multiplication. Also we will say integers are not commutative under subtraction and wonderful. Do I need to prove this, or you understood?
I understand.
Wonderful. Next property is dear associative. Next property is associative. And what does associative say? That you add three numbers in any order. Commutative stands for two numbers. Associative stands for three numbers. You add three numbers in any order, its value won't get changed. Now what does that actually mean? That actually means, dear, that you cannot add three numbers at a time. If I ask you what is 2 plus 5 plus 3, say this. Anyways, you are going to add only two numbers at a time in your mind. You cannot say, nobody in the world can say 2 plus 5 plus 3 is 10. He will say 2 plus 5 is 7 and 7 plus 3 is 10. Means at a time we are adding only two numbers. It is our privilege to add any two numbers of our choice. Now how does this affect in our day-to-day life? Now let's play a game. The game is, I am going to write a number. You have to tell me the another number, so that together they form 10. For example, if I say 9, you will say 1. Alright? And the time given for this is 2 seconds, not more than 2 seconds. Okay, ready? Okay, 4,
6,
8,
2,
7, 3,
7,
4,
6,
6,
4,
9,
1,
8.
2.
Well played. Very well played. I should clap for you. But now the concentration, intensity of the game is going to be more tougher now. And it is not tougher, it is your applying of basic common sense. Now I am going to tell you a number and you have to tell me another number for which it should make 100. Okay? For example, if I say 46, you will say 54. The trick involved here is that this number you have to make 10, this number you have to make 9. Alright, why 9? Because this is going to be 1 carat and the time now given will be only 2 seconds, not more than 2 seconds. Alright, let's play the game. So the question is 23. No, just say 77.
77.
2 seconds, not more than 2 seconds. I don't want to hear any sound like 27. Just say the number, that's it. You have to think in your mind how to make this number 9 and how to make this number 10. Focus on these two numbers. Ready? 54.
40, 36, 46.
46. Be quick, be quick. 69.
21.
31.
No,
dear.
sir, 31, 31.
Okay. 5 mistakes are allowed. Okay. at a stretch, if you can give me 10 correct answers, we will move on to the next step. All right, ready? 72.
28.
Wonderful. 36.
64.
Wonderful. 57.
43.
Very good. 44.
56.
98.
2.
71.
29.
Okay. 25. No, that much time is not allowed, dear. Only 2 seconds. So this is 75.
Sir, I said 8.
You said 8 for what? 25.
No, I said 75.
Okay, you said 70. Okay, I didn't hear. I didn't hear. Okay, that's my mistake. That's a technical problem. So almost you have given 6 correct answers. So 4 more are there. Okay, ready? Okay, let's see. 82.
28.
No,
Sorry.
dear.
18.
Yes. 76.
24.
Okay. 59.
41.
Very good. 73.
27.
Very good. Well done. Well done. You played this game as well correctly. Now the game is going to be much tougher now. You have to tell me a number which will make it 1000. And you should start from here. How? I am giving you one example. You say any number of your choice, 3-digit number.
3, 4, 6.
3, 4, 6. So 3 will be made 9 by writing 6, 5, 4. Alright. You should be saying like this.
Okay.
If you want to play with me, you can play together as well. You want to ask me, I will just tell you the answer. Not more than 2 seconds I will take.
Okay.
Okay? Okay, you let's play for, okay, let's start with you. You can ask me 5 questions and I will give you the solutions, and then I will ask you 5 questions, and if you will say me all the 5 answers correctly, we will stop the game and we will get to more intensity of 10,000. We will go up to 10,000 only. Okay? Now ready. You tell me the number.
734.
So it is going to be 265. Sorry, 266. It is 26. Next number.
66.
666. So it is
Yeah.
334.
813.
So it is going to be 187.
279.
279.
9.
Okay, so it is going to be 721. All right. This is how you should also answer me. All right. So I am going to write the number for you. So the number is 656.
344.
Wonderful. 728.
272.
272. Wonderful. Okay. 743.
257.
Great. 394.
607. 606.
Great. The last question. 818.
181. So 2. Yeah.
182. Well played. Well played. Okay. Okay. So for 10,000, we will go in the next class. We have done enough for today. Enough exercises we have done. So how does this practice will help us? Suppose, for example, if somebody asks you 253 plus 654 plus 747. Now initially you could have added these numbers in the same order, but now I think you can answer this question very easily. Tell me.
1654.
How? Because you
Because,
thought of.
yeah, those two numbers.
So your focus has shifted not just from simply adding, but adding in a sense, in a sensible manner. Are you getting it? So this sensible manner is known as associative property. Most of the children don't know how to use it. They know what is associative property, but what is the use? The use is to add the numbers in a sensible manner. Alright. Now the same things has to be used in a case of multiplication as well. You can multiply two numbers in any order. Sorry, three numbers. You can multiply three numbers in any order. Are you getting it?
Yeah.
These three numbers can be multiplied in any order. Now, how to use this? So, dear, I am going to make you some multiplication tables learn today. Okay? So, let's start. You know the prime factorization already? What is the prime factorization for 10? Tell me.
1, 2, 5.
It is 2 into 5. 1 is not a prime number, dear. 1 is not a prime number. 1 is neither prime nor composite, because prime number stands for only two factors, 1 in itself. And 1 does not have two factors. 1 has only one factor, that is 1. Okay. So 1 is not a prime number. Okay. If I ask you what is 10 into 10, dear, can you tell me?
100.
Hmm?
100.
100. So that means for each 10, I will get each 2 and each 5. You know this? Suppose I say 1000. For 1000, how many 2 you will get? 3 2 and 3 5. For 10,000, you will get how many 2's? 4 2's and 4 5's. For 1 lakh,
5 2s. No, 6.
please write this down. And then I will make you understand some of the tables, make you not only understand but also learn the tables as well. Some basic tables we need to know. What is the table? The table is 4 into 25, 8 into 125, 16 into 625, 32 into 312. You know what are exponents?
Yes.
Okay. That is not in your course. But I knew that you must be knowing it. You are a smart girl. See, this table you might be knowing it already. This also you can easily know it. So you need to remember only these three tables.
Yeah.
And how you can remember it? If you know the exponents, dear, please know that 5 to the power 3 is 125, 5 to the power 4 is 625, and 5 to the power 5 is 3125. This you need to remember. So 5 to the power 4 means 2 to the power 4 is 16. 2 to the power 4 is 16. So 16 into 625. Wherever you will see such numbers, you can easily make it usable. Now how that is being used here, you can see if somebody will give you 16 into 72 into 625. What is the first thing that you will write? 72. How many zeros? 4 zeros. Why? Because 2 to the power 4 is here and 5 to the power 4 is here. Together they will form 4 zeros. Are you getting it?
So can I just write the tables, the one that you wrote before?
Yeah. Why not? Write like this. You write like this as well.
Yeah.
And if you want to write in the shortest form, you can write in this form as well. 10 square you can write like this, 2 to the power square into 5 square. 10 cube you can write like this, 2 cube into 5 cube. 10 to the power 4 you can write like 2 to the power 4 into 5 to the power 4. मुझे एक बार वो भेज देना यार, मेल का लिंक भेज दो क्लास का, अभी भेजो. क्या नंबर? Written, beta?
Yeah.
Okay. Are you enjoying the class?
Yes.
If you could have understood Hindi, I could make it more entertaining. The thing is that I don't know English jokes. I know only Hindi jokes. But I will learn for you. Tamil? Tamil? I need to learn Tamil, right? Okay. Okay, you understood now how we can multiply three numbers in a very quick session?
Yeah.
Okay. So now you know the associative property as well. But the same thing we will say that integers are associative under addition and multiplication. Write down. Write down. Integers are associative under addition and multiplications, and integers are not associative under subtraction and division. Please write these two statements again. Okay. Integers are associative under addition and multiplication, and
Yeah, I wrote that. I'm the next.
okay, non-associative under subtraction and division. Well done. Okay, so we learned three properties: closure, commutative, and associative. Now the next property is distributive property. You know what is distributive property?
Yes.
Distributivity of multiplication over addition. You know this?
Not sure if I know.
Okay. So please write it down. This is the fourth property. This is the fourth property and very important property. And you know, you already use this property. You already use this property everywhere. How you use it? In the normal multiplication scenario. Suppose I ask you to multiply 25 into 17. If I ask you to multiply 25 into 70. Can you do this multiplication horizontally?
Okay, I understood now. Yeah. Yeah.
So first what you do, you multiply 7 into 5, you will say 35. Then you will say 7 into 2, 14 plus 3, 17. Then you will put 0 behind this, below this. Then you will write 1 into 5 is 5, 1 into 2 is 2. And then you will add these numbers. So you will write 4 to 5, right? If I ask you why you added these two numbers, can you tell me? Why you have added 175 and 250? First question. And the second question is, why you have written 0 here? I am having two questions. You do this. Normally you do this only. Everybody does that. My question is, why do we do that? The first question is why we put 0 here, and why do we need to add these two numbers? Tell me.
Yeah. So the reason why we add 0 is because the first time we're just multiplying 25 by the ones digit, and then the next time we're multiplying by the tens digit.
So the
Which
0, so you are telling that 0 of the tens digit that is being written here, because when we multiply a number by 10, we just add 1 0, right? Very good. Why do we need to add these two numbers then?
because we're splitting 17 into 10 plus 7.
Okay.
So
Wonderful. Wonderful. So when we are splitting something, suppose I say 2 plus 2 plus, or sorry, 12 plus 12 plus 12 plus 12. So you say, sir, continuous addition is known as multiplication. You say like that. So these three numbers can also be taken together. So if I take these three numbers together, it will be written as 12 into 3 plus, if I take these two together, it will be written as 12 into. Now in these two numbers I can take 12 as common, and in bracket I will write 3 plus 2. That means I have splitted 5 into 3 plus 2. So this is, I have distributed the multiplication, distributivity of multiplication over addition. Are you getting it? So it is written like this generally: a plus b into c plus d. There are 4 algebraic variables. Please, if you are getting confused, please let me know. I am writing 2 numbers as a plus b and 2 numbers as c plus d. First, what is going to happen? First, a is going to multiplied by c, then a is going to be multiplied by d, then b is going to be multiplied by c, and then b is going to be multiplied by d. These are the 4 terms that we will get. Are you getting it? So with this property, I am going to make you learn the table of 99. You know what is the table of 99? You want to learn?
Yeah.
You will be able to answer in just 2 seconds. Okay? Let's see. Okay, I will give you 5 seconds. Okay, now say this. Suppose somebody asks you, and you can play this game with your class fellow as well. You can ask her, okay, you multiply 99 by any number and I will give you the answer in 5 seconds. Now suppose 99 into 54. Okay, first I am going to tell you how the answer is to be written. So the first number has to be written as 53. You have to reduce this number by 1. Already? Alright? The next two number is to be written as, you have to, what number you have to add this so that you can make 100. Just now we played a game. So the answer is 40. And now let us check.
46.
99 into 54. See this? 5346. Okay. Now this is the trick you are learning, but I will make you understand the concept as well. Suppose 99 into 72. Tell me, instead of 72, what should I write?
71.
And the next two numbers is going to be 28. Alright, let us check it out. So 99 into 72. See this? 7.
Okay.
Nice. Okay.
Yeah.
Now you have the confidence. Okay. Now how this is coming? See this. This 99 can be written as 100 minus 1 into 54. Can I write like this?
Yes.
Okay. Now say this. 100 minus 1 means 54 into 100 is always going to be 5400. And 54 minus 1 is going to be minus 54. Now 5400 can be written as 5300 plus 100 minus 54. We played a game to solve this. And we know that this will be only 2-digit number, so it is not going to disturb 0, 0. So the first number that will be reduced by 1, and the next number means you have to think of a number which can make that number 100. So that is 46. Alright. So now you learn the table of 99 as well?
Yeah.
In a very quick session. How much time it took? Hardly 2 minutes. So how this property is very well in our use, this is how we learn. This is what property? Property of Distributivity property of multiplication over addition. A number can be written as in the form of addition and subtraction as well. Subtraction is nothing but addition of additive inverse. We will come to additive inverse. Okay, don't worry. So right now, have you understood this property as well? Distributivity, and you understood what are the use of this property?
Yeah.
Now how the use is there, let us take one more example. Suppose somebody asks you 528 into 64 plus 528 into 36. Do we really need to multiply these two numbers separately and then add? It is easier to take
28 into 64 plus 36.
Which is equal to 100. And we can easily tell the answer 52800. In the Olympiad, if you ever see, the questions are like this, very easy questions. The thing is that if you understand the concept, you can easily add them, easily multiply them. All right? Any doubt up to here?
No.
Good. Now I will be telling you the last two properties. The fifth property is the multiplicative identity. Multiplicative identity. What is multiplicative identity? So Ila has got an identity. She is a girl. She is in grade 6. She is beautiful. She is in Tamil Nadu or Karnataka? Bangalore. Okay, she is in Bangalore. She is in grade 6. She has got some school, some home, some society. So there are so many identities attached with Ila. Okay, so many identities. The first identity may be you are a girl, you are in grade 6, then you are in Bangalore, then you speak Tamil. So by chance, I know that you love peace, but by chance, suppose there is a fight between a girl and a boy, then you are going to support your own identity. Maybe it may not happen, but most of the cases are like this. If there is a fight between a grade 6 and a grade 7 people, you are going to support your own identity, that is the person who is in grade 6. If somebody from Bangalore and somebody outside the state are fighting together, you are going to support Bangalore. And if Tamil speaking and any other language speaking person are fighting, you are going to support your own identity. So a person does not want to change its own identity. All right. Same goes with the number as well. Same goes with the number as well. You understood what is an identity. So if I say, by what number should I multiply so that the identity of the number does not change? 1. So 1 is known as multiplicative identity in mathematics. Alright, and it is of a great use. Nobody knows that. Means there are many mathematicians who knows that, and because of this we apply so many formulas, we apply so many things to learn linear equation in one variable, linear equation in two variables, quadratic equations. All equations are solved using this multiplicative identity, but unawarely. It is not aware. You do it unawarely, but we should learn. So 1 is the multiplicative identity, and if I multiply a number to get 1, if I multiply a number to get 1, that particular number is known as multiplicative inverse. What is that number known as? Multiplicative inverse, and that is also known as reciprocal. That is also known as reciprocal. So tell me, 2 should be multiplied by which number to get 1?
1 by 2.
Very good. So 1 by 2 is the reciprocal of 2. Now tell me dear, if I want to multiply 3 by 4, by what number should I multiply to get 1?
4 by 3.
Hey, don't be in a doubt. Just be confident here.
Okay, 4 by 3.
Your sentence was like interrogative sentence. It should be declarative sentence. So 4 can cancel 4 and 3 can cancel 3. So we will say this is equal to 1. Alright, any doubt? No doubt. Good. Okay, so we understood the multiplicative identity and the concept of multiplicative inverse. Now the last property for today is the additive identity. Now the story of identity you already know, but in this case we are going to add a number. So tell me, what is the number which can be added to a number so that the identity does not change?
0.
0. Okay. So if I ask you, what should be added to 2 so that I get 0?
Um, um,
Two times you have sounded something.
-2.
-2, -2. Well done. What should be added to 3 by 4 to get 0? What should be?
-3 by 4.
Wow. Well done, dear. So these two numbers are known as, what are they known as? They are known as additive inverse. They are known as additive inverse. Okay, so additive identity and multiplicative identity, don't confuse with the inverse of those numbers. Additive identity is 0, multiplicative identity is 1, but multiplicative inverse is the reciprocal and additive inverse is the negative of that number. Okay, if the number is already negative, suppose I say -8. So what is the additive inverse of -8?
+8.
We don't need to say +8, it is already, we assume that all numbers are positive. We just need to say negative. Okay, we mention this person is very negative, but those who are positive, we don't need to say about them. We expect them to be positive. All right, in the mathematics the same things happen as well. Okay, so by here variable definition of additive inverse, I can say subtraction is nothing but addition of additive inverse. And we can also mention here, today I am mentioning for you, this is the first time that I am writing here for you. It came to my mind just now. Division is nothing but multiplication.
Multiplication of multiplicative inverse.
Yes. See, this is how maths will evolve. We keep on learning, say, some new things on a daily basis. I am sure that you were not known about these things. In the demo class that I took, it was like you are like a goddess. You know each and everything. I am asking you something and you are returning back it to me. You are like a very good squash player, or a table tennis player, or a lawn tennis player, or a badminton player. But today you are on a receiving end. It's good. You learn so many things today, right? This is a fake question that we used to ask, right? So that by any chance the student is going to say yes only. It should not happen. Okay, all right. So, for example, if I say 10 divided by 5, I can write as 10 multiplied by 1 by 5. And if I need to write 10 minus 5, it means 10 plus minus 5. Understood both the concepts? All right. Okay. So integers means we are going to subtract some numbers, we are going to add some numbers, we are going to multiply some numbers. Integers, suppose I ask you, what is, I am starting from a very basic question. What is 4 minus 3? Okay. What is 4 plus minus 3? Yes. What is minus 3 plus 4?
Mine. 1. Wait. Yeah, 1.
Why?
Yeah, 1. No.
In such a simple process, you got confused.
Yeah, 1.
Okay. Let me ask you some more questions. Tell me what is 5 minus 2?
3.
What is 5 plus minus 2? Subtraction is nothing but addition of additive inverse.
Yes, 3.
3. See, okay, sometimes your mic is not working that well. You should
Yeah,
take
I don't know.
you must be more closer to it. Okay. And have you logged in from two screens? Because I am
But
seeing.
I have a monitor, so.
Okay, so your camera should face your monitor. It's looking like that you are looking somewhere else. Like I have a monitor above, so I am looking above. So I sometimes I look at the camera like that. Okay, fine. You are doing great. Okay. So if I ask you what is negative 2 plus 5?
3.
3. So I want you to write one statement. If two numbers are added with a different sign, they are always subtracted. Please mark this. I'm writing a very contradictory statement. If two numbers are added with a different sign, they are always subtracted. If two numbers are added with a different sign, they are always subtracted. Okay. For example, and the smaller number is subtracted from the bigger number, and the final result has the sign of the bigger number. Try to understand a very long statement. It is not a statement, it looks like a paragraph in it. What is the statement? If two numbers are added in with different sign, they are always subtracted, and the smaller number is always subtracted from the bigger number, and the final result has the sign of the bigger number. Let us take some examples. Suppose I say in these two cases, two numbers are having different sign, so you will always subtract. You will always subtract 5 minus 2 without thinking, and then you will write the sign of 5. Okay, let us do some examples. Tell me what is minus 5 plus 2? Opposite sign, subtraction. 5 minus 2, 3. What is the sign of 5? Negative, so the negative 3. Alright, can you do some questions now? Tell me minus 7 plus 4.
Minus 3.
What is 4 minus 7?
Minus 3.
Very good. What is minus 8 plus 4?
Minus 8. Minus 4, sir.
And what is 4 minus 8?
Minus 4.
Very good. Now the last statement. If two numbers are having same sign, if two numbers are having same sign, they are always added. They are always added, and the final result will have the sign of both the numbers.
Sign of 4.
Minus 5 minus 4, both the numbers having the same sign, they will be added, and the final result will have the sign of the both the numbers. Okay, minus 6 minus 4, both the numbers same sign, added, negative 10. 6 plus 4, positive 10. Are you getting this, beta?
Yeah. Sorry. Yeah.
All right. Okay. So any doubt in today's class? Let us revise all the concepts. What are the concepts that we learned today? Closure property. Okay.
Closure property.
Yeah, you keep on saying. I'm listening.
The closure property, commutative property, associative property, and multiplication table of 99, which is distributivity of multiplication over addition, or the distributive property, then multiplicative identity, then additive identity, or property, sorry. Property.
No, it is
and
additive
then,
identity. It is not property, is additive identity only. Additive
yes,
identity.
I know property.
Multiplicative identity.
Yeah, I know multiplicator.
Then multiplicative inverse and additive inverse.
Yeah.
Okay, and then you learn the table of the very tough table of 99, and you learn the you learn the table of 65, 625 as well. Up to 16, you know, 625 into 16 is 10,000. Okay, and 3125 into 32 is 1 lakh. Please remember all those tables. Okay, 125 into 8 is 1000, 25 into 4 is 100, and you learn the play the game of making a number adding up to 100 and 1000. Okay, so with this I'm going to end this class here, because I have another class in just 5 minutes. I need to take a 5 minutes break. From next time onwards, I want you to come 5 minutes early. Okay, when it is 7:30 means you have to be on time at 7:25. All right, any doubt, beta? You liked the class?
Yeah.
Okay, so after the class there might be some rating and all. So you are good in English, you can just rate it there. Okay, chalo, bye. Okay, so for the YouTubers, I'm going to end this class today. This class is in English because my student does not know Hindi. With this, I'm going to end this class. Jai Hind, Jai Bharat. Thank you.